And we are back. Am I? Am I? Yeah. Yeah, I'm back. There we go. Okay. So, I haven't thought this one out too much. So, I'm planning on writing a brainfuck compiler within the TS type system. I have done something like this before where I've tried to write a compiler, but I ran into this issue. This is not merged in yet, but this would have fixed my issue. Um, so what happens is TypeScript starts complaining when the types get too nested. And right now, the state that my old project is in, it does hit that limit quite easily. So there are a few ways to work around this, but yeah, I'm just gonna start the whole thing from scratch and do it live, I guess, this time. And yeah, if I run into the same error, we'll see if there are ways to just work around it. I think writing, like following pure tail recursion for every step would help, and also in some cases, if we can avoid uh, ternaries, that would also help. And also, TypeScript has a new feature which would also help here, which is infer extends syntax. We'll get to it later if you don't know what that is, but yeah, that is another thing that will be incredibly helpful on our journey. Here it is. This is the old project. I'm not gonna touch this. We'll keep this for reference, but yeah, this I'll just show you the error real quick. Here it is. Actually, look at this. Isn't this cool? Yeah, I was so proud of it when I made this. This is basically a test runner for, sorry, here. This is a test runner for TypeScript types. Isn't that fucking awesome? Yes. And I mean, I I guess this also contributed to the error before, where it when the types get nested, it starts throwing an error. So this probably didn't help. But yeah, yes, this thing. If I uncomment this, you'll see that this throws an error. This doesn't work. So it's because of the loop, because we have to recursively go through the types here. But yeah, this is what we'll be building. I'll show you an example that is working. Actually, you can see it here. So in the debug type, whatever we put here will just get printed as a debug log, so you can see the result. When this is our state, the initial state of our system, and this is the brainfuck expression that we give to the type, and the result of that we can see here. And actually we can just pull this out and let the LSP show us the result. What? He isn't okay. I was just crying. Let's ignore that. Yeah, so when we give it, I don't remember exactly what this does, but this is the initial state, and when we run this, we get the result. The cells is the memory. I guess here it zeroes out all of them, and there are 3 cells. I think that's what it means. I don't remember. We'll have to go through the whole thing again. But yes, this is what the result is. And yeah, the car is the current cell. I think that's what this represents. It's the cell we are currently at. Anyways, we're doing this from scratch. It doesn't matter. Yes, this is the hurdle that we need to reach and surpass. All right. Actually, let's move this guy somewhere else so I don't confuse myself. Brainfuck TS types. Let's move it to. Hey, I just noticed something. Brainfuck. I added it to my title on Twitch, it didn't complain. But the moment I was trying to add brainfuck as a tag, it started complaining, oh, vulgar language isn't allowed on Twitch. Oh. But yeah, with the title it's also okay. I can just, it's all fair game. I can use whatever slag I want. Can I just use racist racist slurs in the title and you'd be okay with it? Huh? Is that what this is about? I just move it here. I stop rambling. Take, what is this? Brain fuck. Yes, types again. Get in it. Yarn in it. Oh shit. Yeah, do that. I don't get why it should be a one release. Yeah, whatever. Repository URL. Oh, I totally forgot to do a check for the audio. Give me a second. Let me do an audio test. Yep. Test done. It sounds just as horrible as I expected. Here we are. Why is this guy crying? Let's remove that guy and let's also add a get ignore. Load modules and also star.log. Also star.map and maybe dist if ts generates some file. There we have it. Yarn add types node. Is that necessary? Let it be. TypeScript and types node. That won't be actually necessary, so let's leave that out. Yarn tsc init. Yay. Oh, I hate the init config here. Oh, so many comments. So painful. Let's how do we do? I think global starts with 2 slashes and I delete those lines. dd. Is that how it works? No. Yes. Oh, thank goodness. Wim, I love you. You were my only. Oh, start. Okay. Perfect. No, that would delete the line as well. Yay. I love Wim so much right now. Let's do the same thing without this guy with some spaces because I don't want the extra trailing spaces. How do we do delete everything after? Shift D? No. D end? No. I don't know how to do this. Let it be. I'll just do n and delete the rest. Okay. Here we are. Do we need anything else? I would like a better config, but okay. Let's not worry about that. Let's start with an src index.ts. This would be where we write our compiler, our interpreter actually. Interpreter. Let's just do any for now. So we have something. Okay, let's just start doing something here. I describes equals interpreter. Okay. So yeah, so about the initial state, what we saw over there was we need so the way brainfuck works, right? So you have the current cell, which is 0 or 1 or 2, whatever. You have set of cells, say, let's just give them all numbers. So this example has 6 cells and we're at the current cell. So if the brainfuck expression is plus we increment the 0th cell. If it's, I forgot, is it this? If it's this, we shift over to the next cell, and if it's this, we increment the next cell, and we keep doing that. And I think period is print whatever, I don't remember. Let's also open up what is it? Yeah, so about this, I think if we are not able to overcome this limitation, we might try patching TypeScript. Yeah, we might do that. Okay, what was I saying? Brainfuck. Google, tell me what brainfuck is. Wikipedia might help. I don't want to watch a video for it. This thing would also help. Yay, that gives us something. Is there a chart for showing every... Yeah, here it is. We got it. Or actually, here it is. We got it. Yes, increment the data pointer, which is the current cell that we're at. So decrement it, going it back. I'm guessing it's also cyclic, where if we hit back on the first one, we reach the last cell. I don't know if that's what is expected, or if that's what I want to implement, especially considering the limitation of nesting that we can achieve with TypeScript. So let's see. Increment. Oh my god, my eyes are burning, so this isn't pretty, but it'll do for now. Increment the data pointer. Yes, decrement the data pointer. Output the byte of the data pointer. Okay, except 1 byte of input, storing at value at the data pointer. This we may not be able to do, considering this is the TS type system, so we may not be able to accept any input. Or what we can do is make that a part of the... So we have to give it a list of inputs, and it takes one away from the stack each time, something like that, right? At the end, not right now. I don't want to deal with it yet. So yes, this is how you do loops, where you have this, and you can do loops and shit. All right. Okay, translated as an unconditional jump to... Okay. Do we have a conditional jump? I don't really understand. Okay, so the current cell, when the current cell reaches 0, it stops looping. I'm guessing that's how it works. Perfect. Okay. Let's start this. Oh, give me a second actually. I'll be right back. Okay, where were we at? So we had a currency. So how do we want to represent our state? Let's do this state. I don't know if we should give it an alias because we might hit that limit sooner than we expect. Actually, before we do any of this, we need natural numbers. So the reason for that is in TypeScript, we can't do something like this at the type level, right? If I do 3 plus 2, 3 plus 1, I can't do that. I can't increment a number in the type, which is why we'll need a representation for type for numbers in the type level. So the way to achieve that would be, let's say underscore nat equals, what do we do here? um, let's do nat is either 0 or underscore 0. I think this is like a fun representation of numbers. So, or suck nat. There's no suck, and I don't think recursion is supported here. So let's revisit this. Underscore nat is, let's create a generic thing for it where it can be number and with some symbol. Or let's just do, yeah, let's do prev is declared const prev is unique symbol. This will just allow us to uniquely like access the previous property, but also not allow anyone else to access the property outside the scope of this. So what was this type? The previous number would be a nat, right? So let's do suck. Suck is increment, by the way. Number extends underscore nat equals. So when we're incrementing, we're basically creating the number. Or, oh, this is a little fucky, I guess. N extends nat. Can I do that? Is that allowed? I think so. I can just by default give it null. No, it does not allow that. Null or no, none of that bullshit here. Okay, let's make this optional in that case, because for 0 we can't have this. So or let's give it null. I think being explicit would help. I don't know. Yes, type success is number and priv becomes the old nat, right? And we also have 0. 0 would be 0 and priv is null. There it is. We've got it, ladies and gentlemen. We've got it. Oh, I don't like that actually. Let's just stick with it. Nat is underscore 0 or suck. I still find that funny for some reason. Suck. Hello, what's up? Suck underscore nat. Yeah, I'm a bit fuzzy about that. I don't know how I want it to be. So basically, the purpose of doing all of that is now we can have any numbers. So suck underscore 0 is 1, is a representation of 1. Suck underscore 1, and we can keep going like this. So we have 3, which is basically a pointer to 2, and that's a pointer to 1. So we can also decrement it. So let's also write successor and predecessor, pred. And the predecessor is obviously just going to be n, right? So, no, sorry, n predecessor, prev. My god, what is happening to me? Yes, type of prev is what I meant. There. So now if I want 2 underscore, I don't know, we can just do pred underscore 3. Now that gives us 2. It's basically unwrapping the type that we wrap together. Anyways, so we'll need all these aliases for testing mostly. Let's do up to 5. Let's move all of these guys to somewhere else. Let's create a nat.ts, print this out. Perfect. We'll have to export all of these. Export. Oh, that's not what I meant to do, but okay. Suck. Perfect. We've got our numbers, we've got our natural numbers. All right. Okay. All right. I don't know, I'm a little fuzzy. Import nat from /nat. And here we have our state. A state would be, obviously we have our current cell, which would be nat. We have a list of, okay, we'll also need another type here, which would be generate a list of nats, of given nats. Basically, we need initial state for this. So this will give us some lists. So let's just use generate what? Generate cells, and we give it the number generate list. We give it the size that we want our list, and we give it a number. Okay, so state becomes, oh, this kind of sucks. I don't want that. Can we just do nat, comma, 0? Yeah, no, nat. This will be our state. We'll also have the output in our state, right? So say we're printing something out, so we need that output to be accumulated somewhere. So that will be here, nat, or an array of nats. That will be our output. We might also need input at some point, but yeah, that's for future me to deal with, not right now. Can we access this? Can I do underscore s equals state 0? Does that give me nat? Okay, yeah, that works for me. This will give me, okay, generate list, we don't have that, but okay, that's fine. That works with me. Okay, so size, comma, item, extends nat. This guy also extends nat, equals how do we generate a list of items? Okay, so we start, let's do size extends underscore 0, which is when we've reached our end. That our base case would be to return the generated list. Let's do it like I said. Tail recursion is the way to go here. So let's do that. Nat array and equals nat or just equals empty array. We return accumulator if it's 0, else we this is auto formatting. Let's remove auto format. I don't want to fuck around with it. Okay, size extends. No, it's not 0. I'm a little unsure about this. Okay, let's in default case what we need to do is do dot 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 accumulator and then we add in the type, right? Cannot find underscore 0. Oh, okay. Underscore 0, underscore 1, underscore 2, underscore 3, and also suck. Suck is the most important. We all need suck in our life. We all suck. Yeah, that is not all that helpful, to be honest. Yeah, that kind of sucks. State n. Let's do n extends nat. That'll give us a fixed type. Let's do 3 cells or 4 apparently. 3 cells. Oh, sorry, I did it the other way around. N comma nat. So we'll just. That's not what I expected. Oh my god, I'm an idiot. Yep, I think that's the diagnosis here. I am an idiot. We need for this we need to make a recursive call. I totally forgot about that part. We have here we need to do, yeah, we can just do a recursive call to generate list for this one. We'll need to decrement, which we need predecessor for that. Predecessor of size, item, and we do that. Yes. Did I do something wrong? LSP, can you explain to me what? Okay. Does not satisfy constraint nat. How the fuck does not satisfy the constraint nat? Oh, right. So for 0, the result turns out to be null, which is not a number. So in that case, what we'll have to do is do n extends underscore 0, in which case it will just be 0 for n. Otherwise, we do this. Yeah, yes, that works. Now you're happy. Why is this giving me some hint information? It doesn't matter. Now we get 3 items here because we said state 3. Perfect. This is what we wanted all along. Just 1 second. Testing the audio again. Feel like it kind of screwed up. You know why? Okay, everything is on order. Oh, okay, I had a stroke. Everything is in order. Surprise. Okay, like I was saying, we've got our state to um, generate a list of cells that we're going to use for our compiler. I don't know if I want to keep this alias. I feel like that would contribute to the infinite depth issue, but yeah, let's stick with it for now. We'll remove it later on. We have our state first. We need, let's keep it state. State extends state. Oh no, that kind of screws with my plan, but let's do this for now. And then we have our brainfuck expression, which would just be expression extends string, right? So let's start walking through it, and I'm sure we'll run into issues soon enough, but yeah, expression extends. So the first thing we need to tackle is increment. So let's do that. Extends plus, and then we've got our, is this to infer rest? Yeah, this would be type string. I don't know if this is necessary. But yeah, let's do that. We need to, in this case, we need to, let's add a base case as well, which is extends an empty string, in which case we'll just return our state, right? And then in this case, we need to increment our cell. For now, I'm returning an interpreter. We'll just see if our loop collapses into yeah, let's do this so we can test out our state immediately. State underscore, oh, just a second, my alarms are going off. Okay, yeah, like I was saying, we generate a list of 4 cells and we give it a brainfuck expression for plus 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 plus. Yeah, so this should increment the first cell, I guess, 5 times. Oh my god, we've just started this and we've already run into this issue. Why is this happening? Did we do the thing wrong? Recursion? No? This makes no sense. What if I remove this st type st equals this guy? Cannot find it, let's go for it. Oh, okay. Actually, that one makes sense. What? State. Oh, right. I made a mistake by making this a parameter here. Shit. How do I do this? Let's take an initial cell. Current extends nat, comma this guy extends nat, and give it current and that. Yeah, and in this case we just give it nat comma nat. That should work, right? Don't give me an infinite error again. Okay, this current cell is 0 and this one is 4. No, already haven't started yet. Do we, oh shit, what do we do here? Let's just make this one an empty array. Or yeah, that's appropriate, I guess. What is the problem? We have, okay, so I think what's happening here is when we have a nat, it doesn't know that it can't reach the base case anymore, because nat will never reach a base case, because that's why we have the aliases for numbers. Nat is too generic. So what we can do is identify nat. Nat extends size. We return the accumulator. Shouldn't that have worked? But actually this. Yes. But that doesn't fit with this guy. Okay. Think, what else? Let's not do that, I guess, because that might be necessary. Oh my god. Let's also do this, else never. Or else this guy. Nah, that still doesn't solve the issue. I mean, this is the problem at the end of the day, which is when we have a generic nat here, like we use here, we can't do what we're doing right now. So I don't know how to work around this. Okay. Interpreter, help this poor boy figure out what he's doing in life. Let's move that there. Does not satisfy nat comma nat, which is because of this. So let's do nat array here. Hey, that worked. Aha. Had to do a few hacks, but we finally got it working. Okay, I think that's fine. Let's see what we get here. We get, oh, okay, that's not helpful actually. Shit. Shittity shit. Shit of the highest shit. Oh yes, the default is not nat. The default is 0. Yes, this is what we wanted. We wanted the current cell, which is the first item, the list of cells, which is a list of natural numbers, and the last one is nat array, which we'll figure that one out when we get to it. We don't need to worry about it right now. But yeah, this is where we're at. Or let's have another parameter for it, which is out. But this one would be cells. Let's not cell. Let's name it appropriately. And this one's output. Out extends nat array. And this one goes here. And the third parameter here would just be an empty array for now. Oh, actually, no. Empty nat array now. And this one would just have an array. There we go. We've got our state working like we expect. Okay, so now is the time to increment the guy. So we need increment cell. Right, this would increment, so this accepts the current state nat comma nat. Okay, let's not keep repeating that. Let's do it here. Nat equals nat equals nat. Oh, I don't know if I want to do that. Yeah, let's continue doing this then. Nat comma nat array. There. Okay, so this guy gets a set of cells. We'll see if we can optimize this later, because this would also cause a number of extra nesting, but for now this is fine. Here, what we can do is we need to return the current cell, which is st0. The list of cells, but with the first one increment, or the nth one, state 01, incremented. How do we do that? Oh no. We use suck. I don't know why I find that funny. Every time I say it, I'm just giggling like an idiot. This one would stay the same, st2. So in here, what we'll need is we need head and tail. So we increment the head, or let's do that in line. st1 extends list infer head, comma dot 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 infer tail. Oh, I love this drop. And otherwise you just give it st1, because if it doesn't have a head, we can just return this. Oh, st1. Yeah. Here we need to increment, which is suck. We need to suck edge, and we need to keep this as is. Yeah, that works. Oh, extends that. Perfect. Perfect. We've got it. We've got it. This is the syntax that I was speaking of before, which is we infer extend syntax. Usually what you'd have to do is infer h, and then inside this conditional we do another h extends nat, then we do this, otherwise we do st1. So this has a deeper representation for the type, which leads to the infinite instantiation error or whatever, but this one is better. So let's increment the cell. Does not satisfy the constraint. Okay. st. Why doesn't this satisfy the constraint? Increment cell does not satisfy the constraint. Okay, maybe I need to do as state. Oh wait, no, I can't do that. What's the problem here? All right. What did I fuck up here? Let's see the result of just running something. X equals, oh, I'll have to do y because I've already used x. Increment cell, we give it state state. I mean, it's obviously returning a tuple, which should work with state from, that's what I would expect, but apparently it's not doing that. Yeah, that sucks. Oh, can we instead do, yeah, instead of generating it here, why can't we just do cells, right? So we just accept a list of cells. That way we can just construct the list of cells here, which I think works better. I don't know. Yeah, instead of generating list, we just do cell size or cells actually. And over here, this is just this guy, and this one is okay. Oh, let's not do that. And this one is also a cell, list of cells, and this one, let's not worry about that. this one would be generate list. We give it the size, we give it this guy, initial value, and yes, we got it. It works, but it's still throwing an error apparently. Does not satisfy the constraint. Oh, right. I totally forgot to do the important bit, which is we get rid of that. We do this. Okay, this was the problem, I guess. Does not satisfy that. Why not? Why the fuck not, you stupid? Okay. This one also needs extends in that case, right? This needs to be a list of nats. Perfect. Actually, we didn't need to make that change at all. It would have worked either way, but perfect. Yeah, actually, I'd like it to infer that on its own. Yeah, this is better. There it is. We have incremented it 5 times, the way God intended. What's the thing for decrement? Okay, obviously, my God, I can't believe I just asked that question. Minus is for decrement. Let's implement that then. Let's subtract 2 out of these, so the result should be 3. Let's implement it now. Minus. Actually, before we do that, let's do some tests. So, like I showed before, we had a test runner for the thing for TS types, which was pretty cool. But for now, I need an assert EQ, or should we do it double? Yeah, I think that would be better. Assert would be T extends true equals T. I don't know the value of it, but and then we can do is EQ A comma B equals, yeah, for this we need to do this. By the way, putting it inside a list, being like a unary tuple, it makes the type checking more strict. I think that's how it works, or something like that. But yeah, that's what I'm doing here. So if both of these are true, I return true, otherwise I return false. Perfect. So now I can do here, let's create tests equals assert is EQ, or actually we don't need assert. We can just do true or true array, right? So if we run into something that's false, we just throw an error. Okay, so what we expect in as a result of this is _0, comma _5, commas _0, comma _0. How many cells? Let's just do 3 cells, because I don't want to write that many numbers. And the thing here would be this, correct? Oh, I can't do that. I don't know what part of my dummy brain thought that would be okay. This is const underscore tests. Let's export that as well. Hooray! No. Okay. 0 as shit. We can't do that then. Let's do type. Yeah, let's use assert then. Assert that. Perfect. _5 isn't important. Let's do _5 here. There we go. And if I change the result to 3, it throws an error. Perfect. If I change the input and the size of our list to 7, or there is no 7 but 5, there we go. We get an error again. Perfect. This is what we wanted. So now let's test out decrement, right? So we give it a list of 3. Yeah. So the result that we expect here is, wait, why is it throwing an error? Oh, no. Shit. Let's this actually was a bad idea because I can't see the type anymore. Let's do this. Never. Oh, right. I totally forgot. I need to write the case for it first, which for now let's just give it the state as is. Okay, that didn't work apparently. All right. This goes. Yes, it shouldn't work. That's perfect. Shouldn't work. Okay, so now let's create the same function but with decrement. Here we go. Decrement. I said decrement. I don't know how to pronounce it. Decrement cell. Perfect. So here, instead of a success. Oh wait. Oh shit! I realized a mistake there. This only works for the first element. I only made it work for the first element. We need to make it work for any element. How do we do that? Um, 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 that sucks. The solution I can think of would definitely throw us over the limit of how much nesting we can achieve. Yeah, let's go with that, I guess. Okay, let's put decrement on a halt. Let's put our dicks in a halt before we work on this. Let's fix the issue that we have. So if we are at the first cell, what we expect in the result is underscore 0 comma underscore 5 comma, yeah, this guy. But what we get is something else. Let's see. We still get the first one getting incremented that many times. So we expect it to be the second cell, but we still get the first cell. For that, oh, I hate that. Okay, set tuple at n, I think. N extends nat. We give it a list of array, extends any, and we give it an item to set. X extends any. Okay. That's not. Do we need that? Yeah, we don't need that. All right. What we need here is set tuple at. What's the base case here? N extends 0. If we're at the 0th index, we return. We do this. If we're at the 0th index, we do that. But okay, let's. Oh, this is definitely throwing us off the limit. We'll have to refactor this heavily. Set tuple at 0. This would just be ls extends any array, and we give it x equals this guy. We'll have to fix a lot of this. ls. And this last one is also ls. Yeah. And we don't do suck. We don't need to suck. We can just do x. Set it as the first element. Tail and head. Yeah. Oh, this gives us another problem actually. Fuck. This hurts so much. My god. This would just be any and that. Yeah. Okay, let's just go with the flow. I'm so tired. Set a tuple at 0, we give it the list, and we give it the x. And another case here would be set tuple at n, otherwise it would just have to decrement this guy, and what do we do here? We set tuple as 0. Oh no, we don't need to do that. We give it. My stomach hurts, my brain hurts. I'm gonna go get some snacks. I'll be back. I'm hungry as fuck. I am back, I think. My yes. I always have to double check. Okay. Oh, let me drink some water. Okay, okay. Okay, what were we doing here? Which is, can we do this real recursively? Extends. Um. I don't know about that. Yeah, not gonna work. Shit. I don't know how to do this. Help. Send help. Um. How do we? Is there a way to set? I mean, so the standard approach that I'm thinking of, that I'm trying to do here, is absolute dog shit, because it's definitely going to run into uh, the thing, infinite instantiation thing. So I want a flatter way to do this. We do have to, I mean, it'll be recursive. It has to be recursive, unfortunately. But I wonder if there's a there's a more efficient way to represent this. Mm, shit. Yeah, let's just go with this. Let's worry about that when we get to an error. Actually, at that point, it'll be too late, to be honest. So, let's try it. ls. Wait, why is this? Yeah, and we set up a n. Um, shit, I'm very confused here. Shit. Yeah, being tired does not help. Um, let's not do it this way. Actually, we probably will have to do it that way. But let's do an accumulator. Oh wait, actually this operation would run way too many times. So not having it tail recursive would be an enormous issue. So let's do it tail recursive. Accumulator extends any this. Uh, let's make these proper because extends nat. Oh wait, not extends nat array, and this guy. Yeah, let's let's keep it in. Who cares? Who the fuck cares? Uh, I would also like to do a base case in that case. If it's an empty array, let's just return the list as is. Or let's, yeah, it's the same thing. Otherwise, do that, right? Over here, we'll need to take n items before we get to it. So recursively, we if n extends 0, we return set loop at 0 ls comma. Oh my god, my brain, it hurts. This won't be tail. Okay, this would be tail recursive because now I can just do accumulator, comma, set tuple at 0, and we close it there. This would be x, or is it called x? Oh right, we need to make this nat and nat. Okay, perfect. What? Why are you not okay with this? This is what I want you to do. Oh my god, what did I do? It extends nat. That's more like it. Otherwise, what was that? Otherwise, n extends. Oh no. Otherwise, what we need to do is we recursively call it again at n. We subtract this guy. The list here would be okay. The list here would decrement as well. So ls extends underscore or any comma. Actually, nat comma. Okay, infer head extends nat dot infer tail extends nat array. There we go. And if that is the case, let's just default this to never. Yeah, if that is the case, we predict Yep, yep. We take the tail and we keep going, and here we, okay, also x stays the same. Here we can append this to the accumulator, right? Append the head to the accumulator. Is that it? Let's try this. Type underscore equals this guy. We give it a list, underscore 0 comma underscore 1 comma underscore, or let's just make all of these 0. I don't want to deal with that. Let's make one of these 1. Okay, the item that I'm setting, wait, the first item is the index. Let's do it at the first index, and here would be what is this, the result that I'm setting it to. Okay, 4 arguments and the accumulator, let's make that mat equals empty array. Yeah, perfect. No, is this, no, this is not perfect. Oh my god, it sucks. What is this? It set the first item, but it set it wrong. What am I doing with the tail? Predicate n t. Let's name it tail, otherwise I'll confuse myself. Okay. What did I do wrong? Oh, I forgot to spread this. Oh my god. Stupid. Yes, this is right. We set the first index to 5. Let's set it to the 0th index. Yes. Let's set it to 3rd. Yes. What if we go out of bounds? Nothing happened. Perfect. Perfect. This works. This is exactly what I wanted. Let's go to the next thing. Actually, in the NAT, I don't think we need number here. And also here, because that's we don't have a runtime representation for the number. We just have a NAT. Oh. Why does this fail? Is there a number anywhere else? I guess we're just keeping on second thoughts. We are going with it. Okay, this would be the current cell, ST0, that we're setting. This would be the list of things, and this, the third parameter, is the number that we're setting it to, which will be successor of, oh no. Oh no. How do we do this now? Shit, I should have thought like few steps ahead, because, oh god. Because right now, we need the nth item to set the nth item. But right now we don't have that. So like S1, we can't just do S0 here. Like we can't access it by that index because we're using natural numbers. Oh, we're fucked. Okay. So, okay. Instead of that, can we just do increment at? Instead of passing it an x, instead of this whole thing about set tuple at, what if we do set tuple at becomes increment at? Yeah? Does that sound like the shittiest idea I've ever had? Indeed it does. Let's go with it. Let's not worry about this. This goes here. ST actually. And this one, we don't need this one because now we're changing this guy to be oh, okay. I have confused myself. Oh, he used the confuse. It was effective. No. I don't know how to. We can increment at 0. Yeah, we don't need that either. So let's remove x from everywhere. Increment at 0. This is where that thing happens. So instead of doing this, we can do infer h extends nap, and we can increment it here. Hooray! Suck. Suck the hell out of it. We don't need this anymore. Perfect. Okay. Yes. Now let's try this again. Type underscore res equals increment cell. I mean there's no error there, so I think that worked. But still, I wanna try it. State underscore 1 underscore 0 comma underscore 0 comma underscore 0. And what is the third parameter to state? It's the output. Okay. Yes, we incremented it once. Let's increment it. Let's do it for the second cell. Perfect. We've got it. Okay. I guess. Oh no. Shit. You have to do the same thing for decrement as well. Oh no. What am I doing? Um. Hmm. Okay. I've changed my mind. Let's do it in line. Because can we generalize this operation somehow? TypeScript doesn't have higher kinded types, so I can't just pass suck or thread as a parameter, but I can pass in a flag. What do we call this? Shit. Now we're being creative. Suck becomes, it takes an n. Suck is suck n. Decrement or thread. Let's be consistent. I feel like this is shooting myself in the foot, but I'm gonna go with this. OP. Let's rename this to operation. OP extends E of operation. Operation map. What's the problem? Oh, I'm not using it. Okay. Here, then we can do operation OP. That no, sorry. Operation HOP. That is impressive that works somehow. Oh my god. Don't tell me that is working. It is. Okay, it is working. So, I can also move that up here. Let's do it here and just pass that guy in. OP. And what is the problem? Okay, OP again because it's a recursive call. And here we do suck. There we go. We've got it. We are terrible at this, but we've got it. I mean, we can now generalize this as well. Think that's. I don't know if that helps or makes things worse for me um, in terms of what I'm trying to do, but this, yeah, I think instead of calling it increment, I just do change, right? So %s change, oh sorry, %s, I said %s, increment becomes change or update cell. Oh, there's already update cell, that's duplicate, that's fine. Update cell, G, update cell, cell becomes update cell. Okay, update cell will need suck over here. We all need a little bit of suck once in a while. Okay, that's exactly what I wanted. Now, oh my god, we have committed a sin. We forgot to commit. How fucking disgusting is that? We forgot to commit our code. Init commit is the shit that keeps me fit and lit. Oh my god, that whole. I have to write it all over again. A terrible joke I have to now repeat. Init commit is, with the typo, I'm going with it, is the shit that keeps me fit and lit. Need to type in my password for the GPG encryption commit thingy. We don't need this anymore, which is a good thing. And let's bring this back. Okay, so now I can just do update cell st and give it thread. Oh my god. First try, motherfuckers. First try. Look at me. Look at me. Let's create another file for test, maybe. No. Let's keep it here. Alright. If I do decrement, we get 2 less. There's only 3. We have done it, ladies and gentlemen. We have done it. Yes. The next one, the next operator that we need to deal with is this guy. Data pointer shifting. I think that should be easy enough. Let's write the case for it. Let's write the test case for it first, which would be, so I start at 0. I have 3 cells. I do plus and then I increment the cell and then I do plus plus, right? So what I should get is the first cell would be 0. Sorry, the first cell would be 1. The second cell would be 2. And the third cell would be 0. Okay, let's do that. Let's try it at 1 actually. And also here the result would be, we would be at the second cell because we incremented the cell count once, and here the result is 0, 1, 2. Doesn't that look pretty and cute? Oh shit, that's not what I wanted. This, let's move this here so we can see the result. It's never, because we don't have that piece yet. Let's add it. Increment cell counter, update cell. Okay, that's not what we need to do here. st, let's just give it st. So now the result we get is, yes, it's just incrementing whatever we have at the first cell that we gave it. So what we need to do now is create a new cell. I mean, let's just replicate that first. So yeah, this is again state because it's a tuple. But now I just need to do suck. I'm not giving this operation an alias to save on nesting, but yeah, this is basically it. So now when we check it, 0, 1, 2. And that's what we're getting here. Our test case passes because we're cool. We're cool like that. Let's do the same thing for this guy. Red. Perfect. And now our test case. So we are at cell 1, cell 2. We do decrement. Again, dick. And the moment I say dick, I giggle like a little boy. There it is. It worked. So when we are at the second cell, when we're at the second cell, we increment twice, which should give us 2 at the second cell, and then we decrement the current counter and we increment once more, which gives us 1 here. Perfecto. Let's again, like the good devs that we are, Pete. I'm not gonna say it. Adds, what is it called actually? What is that operation called? Increment the data pointer. Data pointer shift. That sounds so much more computer sciencey. To compiler or interpreter. Actually, I should rename that guy to interpreter in my screen because I feel dirty when I yeah, interpret. I mean, it doesn't matter, but still. Yeah, there is it. There it is. We've got it. Okay. What's next for our tiny little thing? Okay, we've come this far and we haven't had any issues yet, which is good. Let's do an output. Yeah, that sounds good. Or should we do loops first and then do the output thing? Because I mean, since we're not in an IO environment, it's this pure operation, so there's no relevance to outputting a byte. So I think loop would be more significant thing to do here. And also loop is the one that will create problems because loop would give us a lot of nesting of types, which could be dangerous to our health. So let's start a loop. Oh, this would also need to go in state. We need to check which loop we're in. Let's see. Let's just do st here. Let's ignore the 2 things here. Yeah. Wait, it's... Come on, tree setter. You're not supposed to do that. Okay, doesn't matter. Alright, so what we're testing here is... Let's take an example. Is there a simple example for Brainf loops? Here it is. Adding 2 values. What would it do? Start the loop. Let's not do that here. Let's do list of cells. 1, 1, 1, and we're at the first cell. The result, I mean, in this case, obviously it would increment the cell, it would decrement the current cell, which is the first cell here. It would move to the next cell. It would increment it, so we get successor of 1, which is 2. And then we go to the next cell, Oh, we go to the previous cell and do nothing. Oh, okay. Oh, that is pretty cool. So if I do 3 here, I mean, right now this only gets executed once because we're ignoring the loops, but the result that we expect is when first we're at the first cell, we go to the next cell, we decrement the first cell, we go to the next cell, we increment it. So this goes to 2, this goes to 2, and then we come back here, we check if it's 0. If it's 0, we end the loop. If it's not, we keep going. And that brings us to 1, this goes to, that goes to 1, this goes to 2, and then we come back and we see that this is 1, which is not 0. So we decrement it again, we go here, increment it, you get the idea. We're doing a lot of looping. All right, let me go turn on the lights. It's getting pretty dark in here and I'm scared. Okay. Oh, he woke up from his nap. Hi, Ozzy. Okay, ignore me, I guess. I'm not important enough for you. He just sighed. Okay. Yes, that's what I'm thinking. Let's do that. So for doing that, we need to change our state, the shape of our state, because we need to add another thing here that will keep track of which loop we are in, right? I'm a little unsure of how to do that, but yeah, let me think. All right. So, we can just add another item in the list, which would just be a list of, which would just be a list of anything. To be honest, we don't really care about the value. We just need to know. Actually, that would just be a nat, right? The depth that we're in. So when we encounter this guy, we encounter the open paren, we increment that number, and when we encounter this, we okay, if we encounter this and if it's and the current cell is not 0, we do something. Shit, I've lost my train of thought there. Yes, we keep going and oh no, actually that makes sense. If we encounter the thing, we decrement it, go back. Oh no, so what we'll have to do, I think, is we'll have to, oh, why am I recording a macro here? Can you please exit? Okay. So what was I saying? So for loops, I feel like we have to maintain a representation or maintain the rest of the compiler string somewhere, because that kind of I don't like that, because we're walking through the interpreter string, so the code, and when we're at a certain point, we don't have the entire thing. So when we're at the end of the loop, we need to go back to the start of the loop, but we don't have the code at the end of the loop, so we have to store that as well. Fuck. Okay, so I think, yeah, instead of nat, I think we can maintain a list of, yeah, we can maintain a list of code, right? List of string, which would be our states, fourth parameter. Oh no, this is getting out of hand. This would be a list of string. Oh shit, that hurts. Why am I using the state constructor? Do we need it? Can I just do this thing? I feel like it's the same, right? Yeah, it's the same. I don't know. I feel like the errors would be much worse, but at least there's less nesting. So that would be a plus. Let's keep the state constructor for now. We'll remove it when we run into an error. Yeah, here what we can do is we add another thing, which is loop. What loop? Loop stack. I feel like that's what it is really, but hard to tell. Loop stack extends string array. Okay, so yeah, state next one, we just give it an empty or a string array. This guy as well, we give it a string array. Here we give it an empty array. I don't like that at all. I hate it. I hate it so much. State the third one. Oh shit. Ah shit. What is happening? st3. There we go. And yeah, we also have to fix all of this. Shit. I hate this. There's so much. Empty. And this guy also empty. Let's do that multiple times, I guess. Okay. This gives us something. I don't like it. Yet. Hey, wait. Couldn't I have done this here? B extends. Let it be. Let it be. I don't want to think about it. Okay. We've got this. What we need to do now is let's handle. Oh, we'll have to handle both of these cases. So my brain not working. Wait, snack time again. I'm gonna go grab a snack to get some sugar flowing in me. Be right back. Okay, am I back? Am I back? I am back. Always check. Tummy is almost full. Not really, but I'm gonna keep eating till it's full. I've got snacks on standby, so You'll just probably hear sounds of rappers, but let's continue. Let's continue. Yes, what were we doing? We were doing loops. Okay, so for loops, not for loops, but for loops, what we'll need to do here is again st0, st1, st2, 3. Now we've got 3 items. So in this case, what we'll need to do is we need to append, I think, append the code for the rest of the string to here because that's our jumping point, right? So when we enter a loop, when we're trying to exit a loop, we'll need to reach back and interpret back to where we came from. I don't know how else to explain it, but that's where we're at. Come on, it's not my fault that we're doing, um, we're writing an interpreter for brainfuck inside TypeScript types. It's stupid that we're doing this, but we are. So stop it. Stop blaming me. Yes, we've got. Yeah, we are appending the jump point here. What? Okay. Yeah. Here we also need to do another conditional where we check what the current cell is. Right. So this is a current. Oh! I just realized something. We need another function. We need a function that gives us the current cell. Get current cell. Okay. N extends. Oh, we need n and we need the state. Or we just need the state actually. State extends state nat array. Oh, I don't like that. I might give it a default value so I don't have to write it every time. I'm a lazy fuck. What can I say? Okay. Yes. So to get the current cell, we have to first see what index we're at. So if we're at the 0th index, so let's do extends underscore 0. We're at the 0th index. What we do here is we just give the first one, right? We give it or st 1 0. Otherwise, we recursively call back to this guy again. Yeah, I feel like I made a mistake giving it the whole thing because we don't need state here. We just need 2 values. So we need current, which is a natural number, and we need cells, which is a list of cells. Right. So we don't need to deal with the rest of the values. So here this can just be current. If current is 0, we take the first item from the cells. If the current, the else would be a recursive call to decrease this current value. So decrement it, and then wait, I think I confused myself. Do we just give it cells? Yeah, I think so. No, we need to remove the thing. We need to take the tail of the list of cells. So to do that, we can do cells extends. We don't need the head. We can ignore. We can give it any, and the tail would be t or infer t dot 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 infer t extends nat or tail. I'll just name it the whole thing because god damn it. Yes. Yes. We got this, and we just give it the tail because we don't care what the value is because it's not the first one. And else we just return never because we don't have it. Rest element must be an array type. Oh, right. My God. Oh, there's someone at the door. I'm leaving.